The purpose of this video is to look at unit goal 3 from our sequence and series unit. Basically, from here on out, we're going to look at sequences and series that have special patterns. So before, a sequence could have just been any list of numbers. Now we're going to look at something called an arithmetic sequence. So the goal here says be able to recognize, find terms of something called an arithmetic sequence. So an arithmetic sequence is one that has a special pattern to it. This pattern is actually pretty nice. So once we have a good pattern, we'll be able to get some formulas. So if obviously you're watching this, if you want to jot down all the formulas we're going to go over somewhere, that would be good, because basically if we were in class, I would give you a formula sheet and you'd be able to use these formulas. So this first formula is going to be for what's called finding terms of an arithmetic sequence. All right, we'll look at arithmetic series, and then we have another type called geometric sequence and geometric series. All right, so there'll be a total of, that makes it sound like 4 formulas, but geometric series actually has 2 different formulas with it. So there'll be a total of 5 formulas. If you write them somewhere, you can use them for any of the assignments. I would give them to you anyway. All right, so let's talk about what an arithmetic sequence is, and then how we can find any term of an arithmetic sequence. All right. So an arithmetic sequence is a sequence where consecutive terms differ by the same amount. So it's just a fancy way of saying it goes up by the same number. So here's my first term, my second, my third, my fourth. This is arithmetic because they jump up, or they could go down as well, like in the next example. They can go up or down by the same amount. So this goes up by 4, 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 so on. So if I wanted the next term, I would add 4 and get 25. Could add 4 again and get 29. Because this has a nice pattern, it's predictable, and if somebody asks me what's the 100th term, right now it would take me a little while to do them all out to get it, but I could find what the 100th term is. There is some defined number. It's not like I don't know what it is. I don't know what it is offhand, but it is findable. This next example I got just shows you that they can decrease also. This is also an arithmetic sequence. This one's going down by 2, so it's subtracting 2 every time. So subtract 2, subtract 2, subtract 2, subtract 2. If I want the next one, it'd be -7, -9, -11. Once again, if I wanted the 100th term, it is determined. I don't know what it is offhand, but we want to talk about how could we find it without having to go through all the trouble, all right? But this is basically what an arithmetic sequence is. It's a sequence that either increases or decreases, so adds or subtracts by the same amount over and over and over again to get future terms. Because these change by the same amount, their difference is always the same. So we come up with this term called the common difference. The common difference is the difference between each term. So I'm going to symbolize common difference. Difference starts with the letter D, so the letter D will represent the common difference. The common difference can be found, hopefully you know how to read this. The common difference can be found by taking a term and subtracting the term before it. So for example, I could take term 5 and subtract off term 4. Basically, if the 2 terms are next to each other, you can just subtract them. So like if I wanted to get the common difference for these, I could take term 2 minus term 1. 9 minus 5 gives me 4. That's the difference that I would have to jump up to get them. Or I could take term 5 minus term 4. So in this formula, that could be a 5, and that could be 5 minus 1, which would be 4. So if I took the 5th term minus the 4th term, notice it still gives me 4. If you subtract any 2 terms next to each other, they give you the common difference. In this case, the common difference was -2. Notice I could take any 2 terms. I could do -3 minus -1. Now, -3 minus -1 would actually give me -2, because it'd be -3 plus 1. All right. Or I could do 1 minus 3. Or I could do -5 minus -3. So long as I take 2 terms next to each other, the later one minus the sooner one, I would get this common difference. So the number that's represented by the letter D is that jumping amount. So the common difference for this one, D would equal 4. For that second one, D would equal -2. All right, so once we know these, basically we can just make arithmetic sequences. So this one's pretty easy. It gives us the first term, 7. It gives me the common difference, 5, and then asks me to come up with the first 5 terms. So this one, I think it's pretty easy. If I can just type it in, I'll just do it on the screen here. Basically, we know the first term is 7. Now, since I know the common difference, I can use that to get every other term. The common difference means the next term jumps up by 5. So if I add 5, I get the next term, which is 12. Then the next term would be 5 more than that. So if I add 5 to that, I would get 17. And so on. I could keep doing this. Let's put a space between those so it all looks nice. Add another 5, I would get up to 22. And then the next term would be 5 more. I'd get 27. And they only wanted me to get the first 5, but notice I could do this forever. If I wanted to take long enough to find any term, I could just keep doing this. Now, our goal is to get a shortcut for this, because basically, since all the terms are predictable, I could make the sequence, but now we want to look at how we can do it a little faster. All right, so basically, hopefully you get the idea here. This is how I could make sequences. Given these 2 pieces of information, so the real key idea of this slide is, if I know the first term and I know the common difference, I can create the entire sequence. In theory, obviously, it would take me forever to write them all out, but I can go as far as I want in theory. So how do we find the nth term of an arithmetic sequence? Nth meaning if I wanted the 50th term or I wanted the 100th term. The formula's down here. Now, if I were in class, I would show, I'll talk about how I'll get it. Obviously, it's a little, I can't write on this. So I'm going to show the formula beforehand and then talk about how I get that, if you care. To get the nth term, so say I wanted the 50th term, I would need to know the first term, I would need to know the common difference, but I need to go up n minus 1 times. So I would actually subtract 1 and use the number 49 in here. So in this example, why does this predict what's going to happen? Well, you always start with the first term. This tells you to add the common difference, but you do it one less time than what you'd think. And I can explain that through this example. Say I wanted the second term. I would only add that common difference of 4 one time. Say I want the third term. I would add the common difference twice. Say I wanted the fourth term. I would add the common difference 3 times. If I wanted the 5th term, I would add the common difference 4 times. So whatever term I want, I'm going to take the first term, add the common difference one less time than I want. So this is the common difference. This is the number of times I'm going to add it. So if I wanted the 50th term, I would take the first term and add the common difference 49 times. Now, I can't write on the screen, but I'll show it in the calculator. Basically, say I want the 50th term. I'm going to do a sub 1, which is 5. And I'm going to show it in the calculator in a moment. So I'm going to put 5 plus, if I want the 50th term, n minus 1 would be 49. So I'm going to use 49 instead of 50. And then the common difference, remember we found the common difference of this was 4. So I would do this calculation. So if I want a sub 50, I would do the first term, 5 plus 50 minus 1 times the common difference, which is 4. That tells me what is the 50th term. It's the number 201. Notice I didn't have to write out all 50 terms. I can just use this formula. Now, if I spent all the time writing out the 50 terms, you'd see that the 50th term would be 201. But basically, because the arithmetic sequence is predictable, this formula kind of fast forwards for you. Instead of having to write the whole thing out, it just goes, if you give me the first term and tell me how far to go, minus 1, I'll give you the right term number. So in this example, they give you an arithmetic sequence, and they want me to find the 21st term. So using the formula, now this one I'll show on the board, to use the formula, you basically need 2 pieces of information. You need a sub 1, and you need the common difference. So a sub 1 is given to me because there's my sequence. A sub 1 is -3. What's my common difference? Well, you can probably look and tell that it's going up by 4 again. But if you don't know, you can just subtract them. I could do 9 minus 5 would give me 4, or 5 minus 1 would give me 4, or 1 minus negative 3 would even give me 4. So my first term is negative 3, my common difference is 4. So how will I find the 21st term? Well, I'll show you the formula. So this one I wrote out. Basically, the work on the top would be what you would do. You would identify these two things, the first term and the common difference. Then, using the general formula, how will I get the nth term? Well, I want the 21st term. I would take the first term, which is negative 3. Now, I'm going to add, remember to do n minus 1. So I'm going to do 21 minus 1, which is 20, and multiply by the common difference. This whole thing basically comes out as 20 times 4 is 80. 80 plus negative 3 is 77. So what is the 21st term? 77. And I didn't have to write out all of the terms. All right. Basically, hopefully you're finding this isn't too bad. Let me go into, obviously, it gets a little harder. What are the worst examples? Here's one that's a little more advanced, and then we'll get a little more advanced than this. So this one doesn't give you the first term, but you can find the common difference. So if you want to see if you could figure out yourself what the 18th term is, keep in mind you would need the first term. They didn't give that to you, but you might be able to figure it out. You would need the first term, and you would need the common difference. Now, they did give you two terms that are next to each other, so you should be able to get the common difference from that. If you want to see if you can do it yourself, you can pause the video, try it out, see if you can get A sub 18. Since it's a video and you can pause it, I am going to just go ahead right now and show the answer. All right. So if you try it on your own, like I said, you'll be able to see it right now. All right. So what's A sub 18 in this sequence? All right. So here was the logic of my thinking. Basically, I told you in that formula, you just need A sub 1 and the common difference. Now, I wrote out the sequence as if I knew some of them and didn't, which was the case. I didn't know A sub 1. I know A sub 2. I know A sub 3. I didn't know any of the other ones. Since these two are next to each other, you could subtract them and get the common difference. If you do 15 minus 9, the common difference is 6. What's the first term? Well, in this case, the first term, you can basically work backwards and get it. If this is 15, you'd have to go up by 6 to get the next one, but you can go backwards by 6, subtract it off again, your first term is 3. Once you know the first term and the common difference, you can find the 18th term. So what is the 18th term? It's the first term plus 18 minus 1 times the common difference. The first term is 3, 18 minus 1 is 17, and the common difference is 6. So 3 plus 17 times 6, 17 times 6, I believe came out as 102, so hopefully that's right because I didn't check it. But I think it's 102 plus 3, which is 105. So once again, I was able to find that 15 or 18th term, and I didn't have to write out. Now, you could go and write out the whole sequence. The point of this is to not have to write out the whole sequence. So also keep in mind, if we were in class, I could ask, what's A sub, 500? You definitely wouldn't want to spend the time writing it out. You'd want to use this formula, all right? Let's look at one more example that's a little more advanced. This is about as hard as it gets. All right, so now we're given an arithmetic sequence, but now they don't give me the two members next to each other. They give me A sub 8, and then they give me A sub 16. And they want me, basically, the actual thing they want me to find is A sub 30. I have this A sub 1 step in, because remember, if we want to do any work with these, we basically need the first term and the common difference. Now, the problem is I can't just get the common difference super easily, and here's why. Because basically, if we think about the sequence now, I basically have 1, 2, 3, 4, 5, 6, 7 terms I don't know. It's not until the 8th term that I go, oh, I know that that's 16. Then I have 9, 10, 11, 12, 13, 14, 15, And then finally, the 16th term, I know. So it's in this case, it's a little difficult to find the common difference because they're not next to each other. But you might even be able to figure it out. There's a way to get the common difference. Basically, if I subtract these, I can find out how far apart they are. They're 24 units apart. Now, they're 24 apart, but it's over 8 jumps. So 24 divide 8 is 3. So I am able to find the common difference. Now, in order to find the 30th term, I would need the first term. Now, I could work my way backwards. I'm going to show you all the work. So first off, let me talk about how I found the common difference as a formula. So there's a formula for the common difference in general if they're not next to each other. So these two terms weren't next to each other. How do I find the common difference? This is the formula, and I'll show it on my example on the board in the back. So the general common difference formula is to take, if you take any term and subtract it from any other term, so the n and the m are just any number. In my example, we know the 16th term and the 8th term, and I would make the n the bigger one just to make this formula easier. It does work if you don't do that, but I would make the n's the larger number. So this common difference formula says if you take any term minus any other term over the two term numbers subtracted, you'll get what the common difference is. So on the work for that one, I'll show you the full thing, and we'll be able to answer this question. So what's a sub 30 as my end answer? I'm going to start by finding the common difference using that formula. Then I'm going to show you how you can find a sub 1. So how do I find that first term without having to jump backwards so many times? And then finally, once we know a sub 1 and the common difference, we'll be able to find a sub 30. So here's the work.